Velocity and acceleration, motion due to gravity. So, as I was just saying, I feel like we're just really adding on to what we know with position, velocity, acceleration. I feel like a lot of this you already know. It's just going to be kind of, solidifying it. We're going to talk some about signs and what the sign means in each situation. So, starting with position function. So, position, you see it in different ways. They're using x of t here for position. You sometimes see, SB position, I think. Just kind of depends. When we talk position, we're talking just a plain old unit, such as feet. Okay. You already know that the first derivative of the position function is velocity. And when we talk velocity, your units is some type of units per time. So, for example, feet per minute. Okay, so because you took the derivative of the position function, it's position, so feet, in respect to time. And then the derivative of velocity, that was weird, the derivative of velocity is acceleration. So I know a couple of you guys talked about this in respect to the last test, so position comes first derivative is velocity, second derivative is acceleration. Or the derivative of velocity is acceleration. When you look at acceleration, I know, and I haven't counted anything off, but acceleration, when we do those units, it's feet per minute. So distance per time, or in other words, feet per minute squared. Because when you're doing the derivative of feet per minute, it's with respect to time again, and so it's per minute squared. So that time is always squared there. Okay. Some information about signs in this next situation. The particle is at rest or changing directions when the velocity is equal to 0. That is a good word problem information, because you will often be asked, okay, when did the particle stop? When did it change directions? And so you need to know that's when velocity is equal to 0. The particle is moving forward or right when velocity is positive. The particle is moving backwards or left when velocity is negative. So just understanding the signs there. Positive acceleration means the particle is accelerating. Negative acceleration means the particle is decelerating. And then the position function tells us the location of the particle. And I see some of you guys underline. There's a ton of stuff I could underline there, isn't there? So pick and choose what you want to look at there.
I think having taken physics last year, the gist of like that big chunk right there, I pretty much understand.
Yeah, and even if you haven't, even if you're the half of the class that's not the physics people, I feel like it's logical. Yeah. That's, even if you're not one of the physics people, I feel like you can look at that and be like, okay, yeah, that makes sense. I just have to learn it, but that makes sense. So, okay, so example 1. I recall it asked like 3 different questions here. The position of a particle moving along the x-axis at any time in t in seconds is given by the equation x of t. Find the position, velocity, and acceleration when t equals 3. So we're being asked to find the position, the velocity, and the acceleration at time 3. Okay, if we plug in 3 first, what is that finding? That is finding position. So I have a lot to write down, so I'm just going to squeeze that in here. So I'm finding x of 3, which is negative 3 times 3 squared plus 4 times 3 plus 2. Negative 27 plus 12 plus 2. Is it negative 13? Now, I want to put that in words for a moment about what a negative position means. Thoughts on what negative 13 means?
So if you start at a position that's 0, if you go to the positive direction, 13 feet, it'd be positive 13. But if you go to the negative direction, which is usually down or to the left, it's negative 13.
Okay, yeah. I have written position when t equals 3 is 13 units. If we go in respect to the origin, 13 units to the left of the origin in terms there. So, however you want to write it, but I am going to write a sentence here. So, position when t equals 3 is 13 units left of the origin. Okay. So again, it's more than just getting the answer of negative 13, but understanding, what that negative 13 means. Okay? Make sure you understand the meanings behind it. Okay, we got one question done. Now what? We need the velocity at time 3. So what do I do to do velocity? Yeah, we're going to find, you can either note it as, you know what, I think I'm going to move over here because I know I'm going to end up running out of room. So we can note it as x prime of t, which is also v of t. What is the derivative? Negative 6t plus 4. And so if we want the velocity, we're going to need to plug in 3 if we want the velocity at 3. And we're going to get negative 14. Did I do my math right? Okay. Let's put it in words. Velocity at t equals 3 is negative 14. First of all, what would be a generic label we could use there?
Meters per second.
Okay. Except they don't tell us meters. So if we don't know a specific units per second. So velocity when t equals 3 is negative 14 units per second. And what's that mean? Yeah, it's moving backwards somehow. Left, down. I have backwards written in mine. Okay, if we're talking here about a number line, you would think left. Okay. So. Velocity when t equals 3 is negative 14 units per second. And that means it is moving backwards. Or you could put left if you want. Okay. Then we need the acceleration. So what do I have to do for acceleration? Yeah. We're going to do x double prime, which if you want, you could think of it as v prime. And that's going to be a. And what is that? Yeah, the derivative of negative 6t plus 4 is negative 6. What is that when you plug in negative 3? Or 3? Okay. And so when you go to find a of 3 is negative 6. Or in other words, the acceleration is always negative 6 at all times. So, acceleration when t equals 3 is negative 6. Good. Units per second squared. And what does that indicate? Okay. What do I have written down? I've written down 6 units per second squared in negative x direction. Why did I write it?
Well, it could be because it doesn't mean that it's slowing down. Negative 6 units, it means that it's going negative 6 units per second squared in the opposite direction. So it's increasing speed just in the negative direction.
Okay. See, this is where you guys, the physics is fresher in your mind than it is my mind. I always have to stop and think about this, so.
One of the things that Mr. Kevin thoroughly explained.
And this is where I could probably benefit from going and sitting in Mr. Kevin's class, just because I haven't taken a physics class in umpteen years, and, you know.
I wish Mr. Kevin would have gotten these books for physics. Like these little notebooks that we can, that would have been so amazing.
I bet he would have this year.
Yeah. Maybe I should tell him that next year he should.
Well, because this is the first year he's gotten them for anything, right? So I bet he will next year when physics comes back around.
Love you guys. That's gonna help him so much.
So, unless, because he got them for what classes this year?
Well,
Or
You didn't
was
get
it biology for notes? Yeah.
yeah,
Because
Why
their
not
notes
work?
are nice, because I looked through the set.
So he didn't get them for anatomy?
No, for anatomy we have,
We have a
a
colored
separate
book.
book, but it's like a colored book. And it has like, no, but it's like super
It actually
elaborate
helps.
diagrams of
Okay.
the anatomy.
Which
And
I
you
guess
color
makes
the
sense.
different parts in, and it actually does help.
And I think it'd be hard to have these for anatomy because it's not
True.
like working out problems, it's like taking notes.
Yeah, that's true. That's true. Okay. Yes.
So negative acceleration isn't necessarily deceleration, it's just acceleration in opposite direction.
Yeah, so it's, you have to think of, it's increasing its velocity in the direction opposite to the established positive.
Also, you just made that way more difficult. Basically, the object started right here, and instead of going accelerating forward like this, it's accelerating like that, so it makes it negative.
Okay.
Do you get that?
Yeah.
There you go, Ross. It was easier. Goodness gracious.
Then why does it say that?
Funny thing.
Because if it had velocity in the opposite direction, it would be decelerating.
Okay.
But it's technically speeding up in the other direction, not decelerating.
So since
So you're saying
velocity is
that-
negative,
Since velocity is already negative, and acceleration is negative, is normal. But if
Yes.
velocity was positive, acceleration was negative, it would be decelerating.
Yes, because it would have to go, it would have to slow down its velocity first, stop temporarily at 0, and then go the other way.
See, I was trying to think of this in relation to like a ball being thrown, but balls don't really just like so.
Unless you're going on the bounce back, maybe, but.
Well, then that's momentum.
And we're not talking momentum today.
Today, are we talking momentum ever?
Okay, like a car like
She's like-
reversing.
I'm trying to think, do we, I don't do much with it. I'm trying to think, I feel like momentum comes up once, but I can't remember if it's in calc or pre-calc.
I know we did work in pre-calc.
Yeah.
I
I
yeah,
remember
we
that.
did, because I thought it was gonna help me in physics.
Well, because it matched up from when we learned work in physics.
Was it the day of
I think so.
or day after?
It was something like that. Because I remember knowing, like, what it was. At least.
Because I think we talked about it in physics the day before, and we saw it on the notes. We're like, wait a minute, and then we did it the physics way.
Okay. Are we ready to try the next one? The position of a particle moving along the x-axis at any time t is given by the equation x of t. Find the times when the particle is momentarily at rest, the times when the particle is moving to the right, the times when the particle is moving to the left. Also find the times when the particle is accelerating or decelerating.
So are we doing some fancy stuff with some critical values and some zeros here? We just plug a zero in.
Well, we have to find the zeros. It's not about plugging the zeros in, it's about knowing what's going on in between the zeros. That's what we're going to have to start with. So, okay. So, find the times when the particle is momentarily at rest. How are we going to find times when the particle is momentarily at rest?
When the velocity is 0, so take the derivative of numerical values.
So we need to know when our velocity is 0. So let's see. X of t is given as t squared minus 3t plus 2. You're all confident on finding the velocity, I'm assuming, right? So x prime of t, or in other words, v of t, is going to be 2t minus 3. And so when we set the velocity equal to 0, that means I'm setting 2t minus 3 equal to 0. And we're going to get a time of 3 over 2. And that would be in terms of seconds. And what's happening at that point, at time 3/2?
It stopped.
Okay, my particle is, in the words of the problem, momentarily at rest. Right? It stopped for some reason. Did it stop? Did it turn around? Did it... We just know it's some, for whatever reason, at t equals 2/3, my particle is momentarily at rest. So that's technically the first answer. Okay. The second answer is we want to know when the particle is moving right. When is my particle going to be moving right?
When velocity is positive.
Okay, velocity is positive. So we want to consider v of t greater than 0, right? That's our mathematical way of saying positive, is saying greater than 0, which our velocity was 2t minus 3 greater than 0. So if we solve that, we're going to have
When t is greater than 3 over 2 seconds.
Yeah. So at the point when t is greater than 3/2, my velocity is positive, and so that means my particle is moving right. Then we want to know times when the particle is moving left. Yeah. So officially, we want to know when the velocity is less than 0. Or in other words, we want to know when the velocity is negative. So officially, 2t minus 3 less than 0. So yes, t less than 3/2 seconds. And because that's when my velocity is negative, my particle is moving left. And then also find the times when the particle is accelerating or decelerating. Which means, what do I need to find?
The second.
We just need to find second derivative, yes. So we need x double prime of t, or v single prime, or that's a, whichever way you want to think about it. And you don't have to put all those connections, But, those are connections, depending on like a pre-response, open-ended type question on a calc test, those are connections you need to be able to make. Okay, so as simple as putting it this way. What is my acceleration then? 2. Okay, and then that 2, does it matter what t is?
No, because it's always positive, so it's always accelerating.
Yeah. 2 is positive. It doesn't matter if we're at a number less than 3/2, if we're at a number greater than 3/2, it doesn't matter. A of t is 2. That is a positive number, so our particle is always accelerating. What do I want to say? Did I just put, yeah, okay. So particle is always accelerating. Okay. Questions there?
Ross, I think little g was 9.8 and big G was like the 6.6.
Times like a
10
big
to
number.
something, yeah.
It wasn't like 22nd or something like that.
Yeah.
Something stupid.
Yeah, I don't remember. I was just thinking about that.
I'd say 9.8 is gravity, so I just don't know if that's big G or little g.
I think
It's
little
little
G.
So,
Yeah,
I
it
just
was
don't-
like big G was like gravity
Yeah,
to
big G was like the gravitational constant, which
yeah.
is like in the gravity equation.
I think it was the gravitational constant of Earth or something.
Well, I think it is the gravitational constant like in general. Like I think for anything that we ever did.
I got nothing here.
Here.
I got nothing on that one, so. Okay, so what we are going to talk, this random 9.8 number, it's not a random number, it keeps coming up, okay? You've actually seen this 9.8 number like in various like applications of quadratic functions. You'll see that.
So didn't we do like the rockets?
Yep, exactly what I was thinking. So an object accelerates towards the center of the Earth at 9.8 meters per second, or meters per second squared. This acceleration is caused by the attraction of the mass of the object to the center of the Earth and is called acceleration due to gravity. And so,
Little g is acceleration of gravity and big G is gravitational constant.
okay. Okay, now with this, notice 9.8 meters per second squared, you have to be in meters. Okay, when we change to feet, I believe it is 32 feet per second squared, but that would be provided. Most of the time you'll see the 9.8 meters per second squared. I said 16 or 32, I'm pretty sure it's 32. Yeah. Okay. So, now, moving on to the next page. Speaking of, Shively said rockets, we're going to talk about a ball. Okay.
This makes so much sense though. I just put together why the equation is quadratic. Because when you throw a ball in the air, it makes it go out.
I can guarantee I've drawn that for you before in pre-calc and algebra 2.
See, but that just
The connection really just solidified.
you know how much easier calc-based physics would be?
Oh, it would have been amazing.
Yeah.
If we had taken this class, physics would have been way easier than it was last year.
Okay, example 3. A ball is thrown vertically into the air so that its height in meters at any time t in seconds is given by h of t. And so yes, a ball is thrown in the air, it goes up, it comes down. That is a upside down parabola, yes? Thus, notice the height is a negative quadratic equation, right? Negative 4.9 t squared. So, okay. Now, we have 4 parts. We have to find the height. We have to find what time the ball is the greatest distance above the ground, how high the ball will go, and the greatest acceleration of the ball. Okay. Well, we shall start with A. Find the height of the ball and the velocity of the ball when t equals 1. Is that pretty easy stuff? Height of the ball. How do I find the height of the ball at when time is 1?
Plug in 1.
Okay, so h of 1, he called it the position equation. It's also, you can think of it as the height equation here. So negative 4.9 times 1 squared plus 20 times 1 plus 2. So the height at time 1 is whatever 22 minus 4.9 is. $17.1 what? Meters. And meters would have been given in the problem, yes? So that is your height at time 1. Then part A also asked us to find the velocity at time 1. How do we go about finding the velocity at time 1?
First derivative.
Okay, in order to find velocity, we have to do first derivative of t. And what is the derivative? Excuse me, I think I said derivative of t. What is the derivative of h of t? Should be negative 9.8t plus 20. Notice that 9.8 number, yes? Okay, there is your gravity. And so officially, we want the velocity at time 1, negative 9.8 times 1 plus 20. So whatever negative 9.8 plus 20 is,
10.2
yep, 10.2 what?
meters per second.
Meters per second is an appropriate velocity label. And that is our velocity at time 1. I was going to put B down below that. I don't know that I can fit B down below that. You guys can. You guys got all the room in the world down there. I, however, do not. Okay, B. At what time t is the ball the greatest distance above the ground?
So that would be when the velocity is 0. So that'd be,
And why would the velocity be 0?
because it would be stopped at the top of the arc before it comes back.
Yeah, there's that momentarily at rest, okay? It's not that we watch it just sit in the middle of the sky and just hang there. But there's that moment of it goes up, 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 and then it comes back down. Okay, so this is a momentarily at rest thing, which means we want to know when the velocity is 0. Now, think about this a different way if you want. My ball, when is it going to be the highest point? That's also called a max. It's a critical point. And how do you find critical points?
First derivative.
First derivative equal to 0. What is velocity?
The first derivative.
The first derivative.
Oh my goodness.
Yeah.
Is that a good connection to make? So if you're kind of stuck, you know, like for my physics kids, oh, okay, velocity equal to 0. That's a piece of cake, you know. But it's also a critical point because I'm trying to find the max. The highest point is the max. So first derivative equal to 0. Okay, so my first derivative was negative 9.8t plus 20 equal to 0. Subtract 20 and divide. I don't know what that is. I have 2.0408. Is that a rounded answer or is that precise?
That's rounded
Okay.
by 1 digit.
Okay. So I did that because we're in Saxon math and, you know, in calculus we do 3 to 4 decimal places. So, okay. So at 2.0408 seconds, that is when the ball is the greatest distance above the ground. So that is when it finds its max, if you will. Okay, so you can also think critical points, which means you can think derivative equal to 0, if any of that helps there, right? Whatever you need to know. Some of it I know seems pretty basic, some of it you have to figure it out. Okay, that was all that was B, right? So we want C. How high will the ball go?
So we would just plug that time back into the position equation, right?
Okay, so this is the time the ball will be the greatest distance above the ground. How high will it go? Well, we need to know the height. So at this time, what is the height? So yes, you are finding h of 2.0408. So that is plugging in, I almost don't know if I really want to write this out, but oh well. Negative 4.9 times 2.0408 quantity squared plus 20 times 2.0408 plus 2. That's for your calculator to do, right? I have written down 22.4082. Or should I let you guys do that? Sorry. Am I taking the fun out of it? By all means, feel free to check. And what kind of label are we going to have here?
Meters per second, or meters.
This is just a height, so it is just meters. D. What is the greatest acceleration of the ball?
Acceleration.
Okay. So when that ball goes up and comes down, what controls that? And gravity's controlling that, right? Now, officially, think calculus with me. In order to find acceleration, you do the second derivative of the position, or you do the first derivative of velocity, and that will give you acceleration, right? Well, go back to where is our velocity formula? Velocity is negative 9.8 t plus 20. What's the derivative of velocity? Negative 9.8. Does it change based on the time? No. Okay, that acceleration is based on gravity, and so acceleration is constant at negative 9.8. And what's my label there? Negative 9.8 meters per second squared. So if the question is, what is the greatest acceleration of the ball? Well, it's constant. Okay?
Is that realistic for like an actual ball being thrown?
There would be air resistance.
Yeah.
Because I feel like, maybe I'm thinking about acceleration the wrong way, but in my mind, it would be going faster like towards the ground, and then as it gets higher, it'll lose acceleration.
Are you thinking,
So you never lose acceleration like that. You lose velocity.
I say you're thinking of velocity.
Okay.
That's I know, it's,
Shut physics sucks. Whoever came up with that, I know.
Yeah, that Newton guy.
Ugh, yeah.
do I have a mistake up here somewhere, Ross?
So for C, I keep getting 32.8164.
Did you use a negative in front of your 4.9?
Probably.
Here, I will tell you.
As we all grab our calculators, like, okay, who has a mistake here?
I'm not.
I'm leaving it. I wrote it in. I'm not going to change it.
It's 22.
The setup's the same whether I'm
And are you really if you're going back and looking at your notes to do something, are you really going to go back and actually do the calculations?
I got 22.
I did too.
Oh, I'm not swearing it. Not swearing it.
Russ, you have-
Okay.
LOL.
I'm like, I got the same answer.
Laugh out loud.
So, but that's a, lesson to learn when you go to do the math, right? Okay, I think that's our last question, isn't it?
I
Tomorrow
like
looks
this.
scary.
You're also one of my 3 physics kids, so.
It makes a lot more sense now than
If we would have had